Thank you. Hello everyone, my name is Mohamed Abdelhafez, and today I'm going to present the damage assessment of residential buildings subjected to hurricanes and severe rise in Mobile County using NSI and ATTOM datasets. So why damage assessment for residential buildings? Because it's important for targeting investment in risk mitigation, and also important to identify future zoning and building code changes. Residential buildings in general are important for maintaining community stability. So quick recap of the hazard modeling. We have Hurricane Katrina that had landfall in Louisiana, but it also had some impacts in Mobile County in Alabama. And here is the original track of that hurricane. We use the three model grade domains to capture the hydrodynamic analysis of Hurricane Katrina. And then we validated this hydrodynamic analysis into location one in Pensacola, Florida, and also in Dauphin Island. And both of them have a good agreement with the peak of the storm surge during the landfall. Also, we have validated with the high water marks from FEMA, and we found that there is a good agreement around 90% for these 100 high water marks from FEMA, as you can see here in this small figure. And also for sea level rise, we considered NOAA sea level rise projections, specifically intermediate and extreme projections, and we coupled those with the Hurricane Katrina. And here you can see the inundation area due to Hurricane Katrina alone, Hurricane Katrina with intermediate sea level rise, and also Hurricane Katrina with extreme sea level rise. Then for the damage assessment of residential buildings, first we had the ATTOM data, and we integrated that with the Microsoft footprint. And then we used these data since they were the only available data to identify the building types in Mobile County, as you can see in this figure. And then we had found the new NSI data, which has slightly more residential buildings than ATTOM data. So we were curious to compare between these two different datasets. There is around like 15% of buildings are identified by ATTOM data, but wasn't found in NSI data. And similarly, also 21% were identified by NSI data, but missed in ATTOM data. And there is around 80% of residential buildings are captured by both datasets. And here in small figure, you can see a sample of some of those residential buildings locations. And some of them are identified by one of these two datasets. So after we use both of them, the number of buildings are increased from the one on the left-hand side to the one on the right-hand side. But for this presentation, I want to focus on those buildings that have been found in both datasets. And by that, I mean those 116,000 buildings. So we use the Lumberton archetypes to do the in-core analysis for these buildings. And to do that, we had to match or map those buildings to the 4 residential buildings archetypes in Lumberton that were defined by Omar Nofal and his team. And you can see here from using the ATTOM datasets and the information available in the ATTOM data, based on the building types and the number of stories, here are the number of buildings for each of these archetypes. And similarly, we have done the same thing with the NSI datasets, and you can see there is a difference between the number of buildings for each archetype due to the new information we found in the NSI data, specifically the occupancy types. So we want to see how this difference in archetypes and the number of buildings will look like for output of this analysis. So here are the fragilities of Lumberton for each of the archetypes F1 to F4. And here I'm showing the in-core notebook that have been used for this analysis, and now we'll go through that quickly. So first, we imported the libraries, and then we start to import the hazard file, which is the hurricane surge. And then you can see here is the values for that hazard file. And then we start with the ATTOM dataset. We import the residential buildings inventory. And you can see here is the two important information for this analysis, especially the first floor elevation and also the archetype. And then we map that with the fragilities in Lamberton, and then we started the analysis. And then you can see here are the output for each of the limit states and also the damage state for each of those buildings. And then we show the statistics for each of those limit states. And at the end, we visualize this output. And I have a figure here on the left-hand side to show exactly like the number of each buildings, the number of buildings for each of these probability of exceedance for the limit state 0. So like for 10% probability, there is 65 buildings, and so on for like up to 50% probability, there is 67, and then from 50 to 100% probability, there is 63 buildings. We did the same for NSI data. I'm not going to go again for the videos. I'm going to show the results. So the number of buildings are quite different than the ATTOM data. And when we did the same for Hurricane and Katrina and intermediate sea level rise, you can see here are the number of buildings are quite different between the ATTOM dataset and NSI dataset. And you can see like kind of the limit states or probability of limit states are higher in ATTOM dataset compared to the NSI. And similarly, also with the extreme sea level rise, the number of buildings with the higher probability is larger in ATTOM data compared to NSI data. And that's with that comparison, we can conclude that there is a difference between the definition of buildings in these two datasets, and with the new information available inside NSI data, especially the buildings occupancy type, then the damage are different or the limit states are different. And by that, I think I conclude my presentation, and I'm happy to answer any questions.